I want to show a quick video here on how to do backtracing and use the core dump to find what line in your code is causing a crash. And this is on Arduino version 2, which doesn't have the tool for the any of the ESP32 chips. It used to be under tools. There was a tool that was called ESP exception decoder, and it has a terminal, which is right here. And somebody made a patch where you can add this to version 2 Arduino, but it's not compatible with the newer chips. I'm using the ESP32-C3, but it's the same as the S3. And the difference is the architecture. The newer chips are the RISC-V architecture, and the older chips are the tensor architecture. So this will not work. Close that. So on these core dumps, what I'm going to show you how to use the factory command line, which is ESP-IDF. It's one command, and you can get your line number in your code, and then also the line number in the operating system, which not too important on that. And the neat thing is you only need two values. So when your software crashes, you could actually email in on a reboot, save it in Flash because it'll automatically save the dump in Flash, send you an email like we did a crash at this location, and then run this little tool, and then you can see what's happening in your code, or at least what part of your code is suspicious, doing divide by zeros or bad addresses or whatever. So I made a little document here on how to do the backtracing on Arduino. So the first thing you need to do is install the command line interface from Espressif. Here's the download link. It does take about 20 minutes. It takes a while, and it's going to give you it gives you two command lines. There's the DOS type, and then it gives you another one, which is PowerShell. I don't really use the PowerShell. I use the DOS. So the first thing you want to do is open that up. After you install it, just open it up. I just do ESP, find the link. You don't need any sort of special rights or anything. So now they can run all the commands for the chip. You could even, people use this to build when they're using Platform IO. This is the main interface. And Arduino uses part of it. It's built in a little bit, but we get the full thing, and then we can get all the debug tools. Now, step 2, we're going to get the ELF file for your application, and that's the linker file, which is going to convert the address to the line number. And then we want to put that into this Espressif tool. So first we want to make sure we have verbose on our upload checked. So we go to Arduino, preferences, and then upload is checked. So that'll show everything. Then we want to compile. You don't need to have the device connected because it's going to try to flash. And that's what we're going to get is the file that it's going to try to flash with. So I've already compiled. And it's going to be basically the first command that it runs. And so this is the location of the command. This line goes way off of the screen. So it's going to be a lot easier just to copy that line. Control C. We'll go to notepad. I've already put it there, but I'm going to show you. Control V. So this is flashing 4 files that are 4 different partitions. Those are the partition locations. We want the last file, and that's your application. Control C on that. Go to the next step. So there's our code file. Now we got to change the slash because it puts a backward slash, which is going to do a file not found in the command prompt. So they all have to be backslashes, not a forward slash. And then we're going to just change the name here to .elf, because the elf file already exists. So here's that folder. So you have the bin, that's your main program, and then the elf is the linked program. And then there's bootloader and partitions, and then I guess merged has everything. But this is the file we want, but we'll change the name on the command. So we grab that, Control C, just place it right here, Control V, change that to the correct direction, and then change the bin to ELF. Okay, let's leave that right there. Do our next step. So we need the two addresses from the core dump, and that's the main program counter and your RA. These are both program counters. That's for your application. That's for the operating system. So let's grab that. We're going to grab that from the serial monitor. Now, to get the serial monitor to show those, you want to make sure that you have your debug level set to info. And so here's our dump. And all I need is these two numbers right here. So I'm just going to copy those two. Control C. And we'll go over here, paste them, Control V. Then we're just going to construct our command just from this right here. So it's really just this first part, and then the two addresses get added to it. So we're going to go Control C there. Go back to Notepad. I've already doing something different there. And then after the E, we want to put our elf file location. We can do that. And then after that, we want to put our two addresses, but they don't need to be labeled. It's just the order that they're in. Put that there. So now we have, this is our backtrace command, Control C, go to the command prompt, type it in, hit enter, and we get two lines of code out of it, or two results. So we got the name of our actual file of our application. We got line 42. So now let's go, see there's the name. Let's see what's at line 42. It's like, right here, write to invalid address, cause a crash. I'm intentionally causing a crash. And so it gave right the exact line. And then the other one, main.cpp, that's in the operating system. But this will get you on the right track, seeing where this is. So on my GitHub, Nathan GW, I'm going to put simple application to send an email of basically the core dump, so that products in the field can email in whenever they're dumping, and then I can see if there's any sort of problems in the code. Because it does take your code's not fully debugged until you get 1,000 units in the field, and they're not calling home very often. I hope you like watching this video. Thanks for watching.